Okay, so we got problems 25 through 30 here where it says excluded values. Now, excluded values are values that should be left out or should not be included. You'll sometimes hear this be called undefined values. And you always want to focus on the bottom here. So we have a numerator, but it's not going to be relevant. We're going to focus on our denominator and we're going to factor it. Okay, sometimes you don't have to factor it. Here we do. So we got x plus 9, x minus 6. And yeah, the x minus 6s do cancel, but that's not relevant here. We want to exclude any values that make the bottom 0 because in mathematics, you can't take something and divide into no pieces. That doesn't make sense. So we say that it's undefined for such values. So when we're dealing with fractions, we have to be aware of the fact that with variables on the bottom, there's a capability of the bottom to be 0. But we need to take note that the bottom cannot equal 0. Okay, so in this case, we can't let x plus 9 equal 0. Also, we can't let x minus 6 equal 0. Because if in either case, if x plus 9 equals 0, you'd have a 0 here times whatever this is would still make 0. If we let x minus 6 be 0, same thing. This would be something else, but something else times 0 is still 0. And even if those cancel, we have to go back to the original problem. So it's the fact there's a cancellation is not relevant. So to get those excluded values, I solve each of these. So x cannot be negative 9. Okay, that's one excluded value. And x cannot be, this is an equal to slash to it. X cannot be 6. So my two excluded values here are negative 9 and 6. If I put either one of those into the denominator, you're going to get a 0, which is forbidden in math. Okay, so you'll do the same thing on your 25 through 30. On 31 through 35, you're dividing with it already factored for you. You may remember from years gone by that when you divide fractions, you keep change flip. That is, you multiply by the reciprocal. So we're going to keep the first fraction. We're going to change this operation to multiplication. And we're going to flip the second upside down. Keep, change, flip is what you've heard in the past. Okay. Now this is no different than what you saw when we were simplifying earlier. We just have two fractions instead of one, but we still have a defined top and a defined bottom. So anything that's on top and bottom can be canceled out. That includes this 8 and 4. 8 divided by 4 is 2. So my answer here is going to be 2 times x plus 6. It just so happens that the entire denominator was canceled, which is fine. Okay, it's technically 1, but we don't have to write 1 because dividing by 1 doesn't do anything. You could, if you wanted to, also distribute the 2 there, but a lot of times it's not done here. All right, finally, we have this situation where we're multiplying. Okay, so we're not going to flip because it's multiplication, but it's not factored. So we got to work on factoring this. And we have really all kinds of scenarios here. We have a plain expression that can't be factored. We have this typical trinomial. Pause and think about it if you want to what that factors into. Okay. Factors of 7 that add to negative 8 are negative 7 and 1. Here we have this conjugate pattern or difference of two perfect squares, a lot of people call it. What times itself, what multiplies give you negative 49 by adds give you 0. Or you can think of it as just simply taking the square root of each one if you recognize the setup and making 1 plus and 1 minus. Okay. And then right here is a GCF. Okay, you always look for that GCF. We didn't have a GCF in the other corners. And now it's the same deal. We've got a long top and a long bottom here. Cancel out anything that shows up in both. Okay, so I'm left with x plus 7. Now on the bottom, if you don't distribute, which is fine, you would have to retain the parentheses. There's no reason to keep the parentheses on top. There's nothing being multiplied times x plus 7. Okay, so that would be my solution there, or excuse me, my product there.